I'm Professor David Farina. In today's lecture, we're going to be discussing the terrestrial planets, the surface of Mars. Let's get started. The surface of Mars is an amazing place. It holds two solar system records. The first of these solar system records is the huge Valles Marineris. Valles Marineris is similar to the Grand Canyon, except for the fact that it is as wide as the Grand Canyon is long. It's so long that it could stretch from Los Angeles to New York City if it were able to be placed across North America. Valles Marineris is the largest canyon in our solar system. The other major feature, as you can see off and to the left here, is part of these two volcanoes. There's actually a third one off to here called the Tharsis Bulge. The Tharsis Bulge is about the size of North America, and it rises about 10 kilometers above its surroundings. The northern parts of Mars are mostly rolling volcanic terrain. These volcanoes are no longer active, they are dead or dormant. The southern hemisphere is a very heavily cratered highlands, and it's about 5 kilometers or so above the surrounding northern portions of the planet's surface. The assumption is, as a result, that the northern portion of the planet is younger than the southern hemisphere of the planet because the cratering is significantly less. This means that the northern hemisphere must have lowered in elevation and then flooded with lava. It's an interesting concept to think of. Here's a picture in false color imagery where we can see at the top portion is more blue in color, showing you that it's lower than the average, which averages here are given as yellow or zeros. The average northern hemisphere elevation is lower than the planetary average, whereas the southern hemisphere of the planet is higher than the average elevation of the planet. So as we look around here, we can see Valles Marineris making up a good portion of the surface. Keep in mind this has been stretched to fit on a two-dimensional screen. So this represents a much, much larger portion of the surface than it might look like. In this type of a projection and map-making technique, we actually cause things that are in the central portions or equatorial regions to appear much smaller than they actually are, and things towards the polar regions to appear much larger than they actually are. So it might look like Valles Marineris is tiny here, but it's actually very big. Same thing with the Tharsis Bulge here, and the biggest volcano in our solar system is Olympus Mons, part of that Tharsis Bulge region. Now, also on this is a number of various missions to the planet Mars. We have here the Phoenix lander, which we'll talk about in a bit. We have Vikings 1 and 2, which are the landers that we placed on Mars first. We've got the Pathfinder, which is a rover that landed as well. We've got Opportunity and we've got Spirit, which are two rovers that are on the planet's surface and just most recently died. And we've got the Curiosity rover, which still is traveling across the surface of the planet to this day. In the future, we plan on sending other rovers, like the Mars 2020 rover, which are going to do further exploration of the planet's surface. Mars, as I said, has two main solar system winners. And the second one of these record holders is Olympus Mons. So Olympus Mons is a volcano. It's 700 kilometers in diameter. It's 25 kilometers high, and it has a caldera, which is a collapsed region in the center, similar to a crater, where the surface has collapsed in, where there used to be magma, which is 80 kilometers in diameter. Now, it's cut off at the bottom here. It says 4 other Martian volcanoes are only slightly smaller, and those are part of the Tharsis Bulge region. Mars appears to have water that has run across its surface in the past, and we can see evidence of this from the image on the left, which is from Earth, compared to the image on the right. Of course, the images from Earth, these are river channels, a braided river, a meandering river that kind of goes back and forth, and very similar features are seen on the surface of Mars, but these do not include water to this day. Now, these Martian river channels don't appear to come from any kind of valleys and mountains from above. These are thought to be some sort of flooding event or maybe an outwash of material that was underground water that somehow melted and leaked across the surface in a flash flood. There's a zoomed in picture of those flooded regions. This is another image of a picture that might have been some sort of ancient delta. You can see here's the headwaters of the delta, and then it comes down, and you can see kind of that delta shape, a fan shape here, where the water may have leaked out into. And within this region, you can see, we're going to zoom in. Here's the region we're zooming in on. And here within that is the Holden crater. And you can see that within this Holden crater, we've got this feature right here, which shows the edge of the crater has been eroded away. This gives us an understanding of the amount of activity, both by wind and water, that have formed and shaped the surface of the planet over time. In this image, you can see ejecta from the central region of a crater, and you can see how the ejecta blanket here has an apparent muddy look to it, indicating that water may have been involved in this process. Now, more recently, we've discovered through observing spacecraft that gullies are able to form in modern times, in present times, through the release of a very briny, which is salty, water substance that leaks out from the underground surface. Here's an image in 1999, and here's yet another one in 2005, and you can see right here is some of that little water, briny stuff leaking out of the side of the crater, the side of this hill. Some images from the surface include this first ever Viking photo and our modern times of the Curiosity rover, which is once again currently on Mount Sharp in Gale Crater on the surface of Mars. And it just took a selfie of itself. In the past, we've used other landers like the Phoenix lander to determine what was happening at different places throughout the surface. And the Phoenix lander is important because it is the only lander to have gone to the northern poles, where we know that under the surface there is in fact now water ice, as you can see in this image. So they took this backhoe-like bucket, they scooped into the soil, and directly below the surface we found water ice. This is very important to potential habitation, both by humans at some point, but potential for life on the surface even to this day that may be just below the surface on Mars. Let's discuss Mars's internal structure as compared to the Earth. So you can see here, compared to the Earth, Earth has a very, very large core and large mantle. The planet Mars also includes a pretty sizable core for its overall size. However, because it's significantly smaller in scale than the Earth, it has gone cold. Mars no longer has a molten core, and as a result, it has no magnetic field. As a result of its lack of a magnetic field, it lacks an atmosphere. So Mars is, well, it doesn't completely lack an atmosphere. It has only about 1% the atmosphere of Earth's. So Mars is a very interesting world. I hope you liked this video. If you did, please click that like button. If you'd like to learn more, please click subscribe. And if you'd like to get a notification each time I make a video, please click the bell at the bottom. Thanks again, and have a great rest of your day.